Off Lecture. Learn beyond class.
Hi friends and welcome to Off Lecture, Learn Beyond Class. And this is chapter 1, Patterns in Mathematics. So before starting going deep into this chapter, let me give you one example. I'm going to write 5 numbers and I want you to tell me what is something interesting about them. 1, comma 3, comma 5, comma 7, comma 9. What do you notice? You probably said they are odd numbers. Yes, they are definitely odd numbers. Good. This is what everybody sees first. और ये बिल्कुल सही जवाब है, पर मैं तुमसे थोड़ा और चाहता हूं क्योंकि ऑड नंबर्स तो दिख ही रहे हैं. ठीक है. Now I want something harder. Let's add them up as you go. For example, 1, then 1 plus 3, then 1 plus 3 plus 5, then 1 plus 3 plus 5 plus 7 and so on. What do you get? If we check this, we will get 1, comma 4, comma 9, comma 16, comma 25 and so on. Now tell me what these 5 numbers are. Sorry. Now tell me what these 5 numbers are. Squares. This can be one guess. Yes, every single one is a square. 1 square is 1, 2, 1 square is 1, 2 square is 2, 3 square is 9, 4 square is 16, 5 square is 25. देखो क्या हुआ अभी, हमने ऑड नंबर्स से स्टार्ट किया था और जैसे ही हम ऑड नंबर्स को सम करते गए हमेशा हमें आंसर में एक स्क्वायर नंबर आता गया. 1, 4, 9, 16 and 25. And this is what you have to keep in mind throughout this chapter 1, that is patterns in mathematics. Every numbers and shapes follow some rules, and this chapter will help you find them, explain them and predict them. Okay, so let's move on further to our first slide, that is what is mathematics. Before we go further, answer me honestly. If I ask you what mathematics is, what you would say? Most students say something like maths is about numbers and calculations. That is, maths is about numbers and calculations. This is not wrong. This is partially right. A small part of it. It is like saying reading is about the alphabets. But if you ask any mathematician and you get a different answer. Mathematics is a search for patterns and for the reasons behind them. That is, it is search for patterns and for why they exist. In the large part, maths is a hunt for patterns in the numbers, shapes, and word around us. Okay. That second half is what separates a mathematician from a calculator. A calculator can tell you 1 plus 3 plus 5 plus 9 is equals to 16, but it cannot tell you why that will always be a square. Okay. And once you look for the patterns, you will find it everywhere, in nature, at home, in school, in the motion of sun, moon and stars, in games and cooking. Okay. For example, if you see, this is an example of sunflower. This is a sunflower. Okay. And this sunflower, if you see the seeds pattern, it seems to be spiral. It seems to be spiral in nature. Okay. Later on, we will see what kind of spiral or what kind of specific mathematical pattern it represents. But for the time being, let's understand that in the sunflower seeds seems to be in spiral. And this is honeycomb. Everyone have seen honeycomb? Once you look for the patterns, honeycomb cells are hexagons in nature. Hexagons means the shape which has 6 sides. 1, 2, 3, 4, 5, and 6. The sun traces the same arc every day. This is another example. ओके, तो याद रखना, मैथ्स का मतलब सिर्फ कैलकुलेशंस नहीं है। पैटर्न्स ढूंढना और उसके पीछे की वजह ढूंढना, ये दोनों मिलकर मैथ्स बनती है। कैलकुलेटर तुम्हें सिर्फ जवाब दे देगा, बट मैथ्स वजह बताएगा। कैलकुलेटर वजह नहीं बता पाएगा कि ऐसा क्यों हो रहा है, बट मैथ्स आपको वजह बताएगी। वजह वाला हिस्सा ही असली मैथ्स है और वही मार्क्स भी देता है। वन मोर, लेट्स ट्राई वन मोर क्वेश्चन। सो इज मैथ्स एन आर्ट और साइंस? मैथ्स आर्ट है या साइंस? आर्ट है या साइंस है? Yes, it is both. And here is the reason. Spotting a pattern takes imagination, and imagination is art. You spotted a pattern in the honeycomb, that is hexagon, is art because you have used your imagination. Proving it that this is an hexagon, it takes rigor, and rigor is science. So maths is both art and science. Those who are art lovers, those who are science lovers, it means that you are both maths lover. Also, finding patterns is a creative work. So mathematicians call maths both an art and a science. Okay. So now we know that maths does not stop at which pattern exists. It asks why the pattern exists. Okay. Now let's do one activity, like where does this maths helps us? Where does this maths help us? The question is, give other example where mathematics helps in everyday life and say how maths has pushed humanity forward. Let's give you a model answer for this. Let's see. The situation is one ordinary day. So if you are going for shopping with your parents or you are alone, adding up the prices, checking the change, comparing offers per kilogram, all are the examples of application of maths in real life. Second one is travel. If you are thinking about travel, reading a clock, working out speed, distance, arrival time, delay time, destination time, everything is maths. If you are imagining about building, measuring the area, angles of the houses, bridges, and how they stand safely, all includes maths. If you are talking about medicine, patterns found in genomes helps doctor diagnose and treat disease. So there also maths is applied. Then if you are talking about space, when you look up, when you see a rocket launch, everything, there is a pattern in the motion of planets that gives us gravitation, how satellites are launched, how what is the path taken by rockets, everything includes math. So there are so many examples where mathematics helps us in everyday life, and this is how maths has pushed humanity forward. Okay, now let's start with patterns in numbers, the most basic patterns that we find in all of mathematics. Okay, so the most basic patterns live in whole numbers: 0, 1, 2, 3, 4. This is the simplest numbers and the richest source of patterns. Whole numbers starting from 0, comma 1, comma 2, comma 3, comma 4. This is known as whole numbers. Okay. And the branch of the maths that studies them is called number theory. What is number theory? The branch of maths that studies pattern in the whole numbers is known as number theory. Okay. And what is number sequence? A list of numbers written in a fixed order made by a one clear rule. That is, all the numbers that is present in that pattern or in that sequence follow a single rule is a number sequence. So there are two words in that definition that are doing all the work. Can you guess those two words? Yes, fixed order, fixed order and वन रूल, दोनों वर्ड्स जरूरी हैं, एक भी निकल गया तो डेफिनेशन टूट जाएगी. लेट्स सपोज इफ आई राइट 7 2 9 4, what you will call them? Try to find some pattern. Do you see any pattern? No. Yes, there is no pattern in these numbers, so these are called as list of numbers. It is not a number sequence. Okay, so there is no rule, there is no fixed order, these are randomly selected numbers, so this is just a list of numbers. तो सीक्वेंस की डेफिनेशन याद रखो, नंबर्स की एक लिस्ट फिक्स्ड ऑर्डर में और एक क्लियर रूल से बनी हुई. दोनों चीजें जरूरी हैं, अगर रूल नहीं है तो वो सिर्फ एक लिस्ट है, सीक्वेंस नहीं. ओके, now let's see some of the famous sequences that we should know. There are 10 sequences, 10 examples of number sequences, and we see them one by one. So the first one is all ones. If you see, there's a diagram. This includes all ones, 1 comma 1 comma 1 comma 1. So nothing is changing, every digit is a 1. So this is also a number sequence, the same number repeats forever. Second is counting numbers, that is 1 comma 2 comma 3 comma 4 comma 5. What pattern it is following? That is, we are adding 1 each time. First we start with 1, then we add 1 to this 1, we get 2, then we add 1 to this 2 to get 3, and then we add again 1 to this 3 to get 4, and so on. So we are adding plus 1 plus 1 plus 1 every time to get this counting numbers. Okay, the third one is odd numbers, 1 comma 3 comma 5 comma 7 comma 9. So in counting numbers, we were adding 1. But if we start adding 2, when we are starting with 1, then it will be a sequence of odd numbers. That is, 1 plus 2 gives you 3, 3 plus 2 will give you 5, 5 plus 2 will give you 7, 7 plus 2 will give you 9. So what we are doing is, we are adding 2 to every number starting from 1. Then what is even numbers? Even numbers is also a sequence, but it will start with 2. We are adding 2 only here, but this sequence will start with 2. That is, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, and 8 plus 2 is 10, and it will go on further. Then comes triangular numbers. What we are doing here is, we are first adding 2, then we are adding 3, then we are adding 4, and so on. So let's suppose we have 1, we have added 2 here, so we will get 3. Now we are increasing this 2 with 1, so we will add 3 here to get 6, then we are adding plus 4 here to get 10, then we will add plus 5 to get 15, and so on. Okay, so these are the first 5 rows of table 1, that is the examples of number sequences. But let's stop here for a bit. If you see the triangular numbers, what is different about the triangular numbers compared to the 4 above them? If you see the first 4 number sequences, there is a same rule that has been applied, that is, we are adding plus 1 or plus 2 to every number. Okay, but here the gap itself is changing. In the others, that is all ones, counting numbers, odd numbers, even numbers, the gap was fixed, but here it is growing also. It starts from 2, then it goes to 3, then it goes to 4, then it goes to 5. एंड ये एक बहुत काम का ऑब्जर्वेशन है. जब गैप फिक्स्ड हो तो सीक्वेंस आसान लगती है और सीक्वेंस समझना भी आसान होता है, बट जब गैप खुद बदलने लगे तब तुम्हें गैप का भी पैटर्न ढूंढना पड़ता है. ओके, सो जो आप गैप देख रहे हो ट्रायंगुलर नंबर्स में +2 +3 +4 +5, ये भी एक पैटर्न से मूव कर रहे हैं। ये एक छोटा सा फर्क आगे बड़े क्वेश्चंस में हेल्प करेगा। सो दिस इस पैटर्न को ध्यान रखना। नाउ लेट्स मूव टू द नेक्स्ट सेट ऑफ sequences. The first one is squares. The first one is squares. So what we are getting here, every number is times itself. That is, it is a square number. That is, if we start from 1, 1 is the square of itself. That is 1 square, or you can write 1 times 1. If you talk about 4, 4 is the square of 2, which is nothing but 2 times 2. If you talk about 9, 9 is also a square of 3, which is nothing but 3 times 3. That is a number's time itself. So squares is also a number sequence. Then we have cubes. Cubes means 1, 8, 27, 64. Here we were having the squares, but here we are having the cubes. That is 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, and 5 cube is 125. So it goes on n times n multiplied by n multiplied by n. So this is known as cubes number sequence. Then comes Virahanka numbers, that is 1, 2, 3, 5, 8, 13. That is the next number is the addition of the last two terms. Okay, and this is a very interesting pattern. What we are doing is we are adding the previous two numbers to get the new number. How it is working, let's understand here. So if we start with 1, or if we start with 1, so what are the previous two numbers? It is 0 and 1. So the addition of these two numbers will give you 1. Okay. Now to get the next number, we have to add these two numbers, these two previous numbers. So we will get 2. Now for next number, we have to add these two previous numbers. We will get 3. Now to get the next number, we will add these two numbers. We will get 5. Now to get the next number, we have to add the previous two numbers. So 3 plus 5 is 8. Then we will add the previous two numbers to get the next number, which is 13. And this will go on. This is known as Virahanka numbers. The other name of this Virahanka numbers you will find is Fibonacci series. Fibonacci series. Fibonacci. Okay. Then comes powers of 2. That is doubles each time. Every numbers doubles each time. That is 1. Then this is 2 raised to power 0. Then 2, which is 2 raised to power 1. That is simply 2. Then it is doubling each time. That is 2 times 2, or you can say 2 square, or you can say 2 times 2 is 4. So what will be 8? 8 will be 2 times 2 times 2. That it is doubling each time. So 2 times 3 is 8. Then we have to double 8, means 2 times 2 times 2 times 2, which is nothing but 2 raised to the power 4, which is 16. To double 16, we will multiply again it by 2. So 2 times 2 times 2 times 2 times 2, that is 2 raised to power 5 is 32. It means the number is getting doubled each time. Okay. And similarly, we can calculate the powers of 3 also. So we'll start with 1, which is 3 raised to power 0. 3 raised to power 0, or any number raised to power 0 is 1 only. Then 3, then 9, then 27, then 81. So what we are doing is we are tripling the number each time. So this is 3 raised to power 1. Then we multiplied by 3. So we will get 9, or 3 square. Then we will multiply by 3. So we will get 3 cube, which is 27. Then we will multiply by 3, which is 3 raised to power 4, which is 81. And this sequence will go on. Okay. So the next numbers will be 243, then 729. That is 3 raised to power 5 and 3 raised to power 6. Okay. So these 10 sequences पूरे चैप्टर की बैकबोन है. 4 में गैप फिक्स था, आपने देखा. इन दीज 4 सीक्वेंसेस गैप फिक्स था, जैसे ऑड नंबर्स एंड इवन नंबर्स. पर ट्रायंगुलर नंबर्स में गैप भी खुद बदल रहा था और वो भी एक पैटर्न फॉलो कर रहा था. ओके, ये फर्क अगर हमें समझ आ गया तो ये बहुत काम आएगा आगे. And one aside thing worth knowing is the word calls Virahanka numbers the Fibonacci series after an Italian mathematician. Okay, I have already told you this Virahanka numbers is also known as Fibonacci series or Fibonacci series. It's just a pronunciation. But Virahanka described them in India roughly 500 years before Fibonacci, while counting the rhythms of Sanskrit poetry. So you can imagine yourself that a mathematician is reading a Sanskrit poetry, and in Sanskrit poetry, he identified a mathematical pattern. So, how complex it would be. Here you can see it is very easy. Like when we understood how the Fibonacci series or Virahanka numbers are progressing, we are finding it very easy that the next number is the addition of the previous two numbers. But think of 500 years back where Virahanka, while counting the rhythms of the Sanskrit poetry, identified a mathematical pattern in it. Okay. So this is all about the 10 sequences that we see very frequently in our maths.